We all know about black holes, those invisible monsters that swallow light and warp space-time. But some scientists believe black holes might not be what we think. There's a theory that something even stranger could be lurking in their place. Gravastars. A gravastar, short for gravitational vacuum star, is a hypothetical object proposed in the early 2000s by physicists Pawel, Mazur, and Emil Mottola. The idea challenges the traditional concept of black holes by replacing the singularity and event horizon with something more exotic. Instead of a core that collapses into infinite density, a gravastar has a thin outer shell made of incredibly dense matter. Inside that shell is a vacuum, a space filled with dark energy-like material that exerts outward pressure. This balance between the inward pull of gravity and the outward push of this vacuum energy creates a stable object that, from the outside, behaves almost exactly like a black hole. So why propose gravastars at all? They were introduced as a possible solution to the paradoxes of black holes. One major issue is the information paradox. According to quantum mechanics, information should never be lost, but black holes seem to destroy it. Since they don't have an event horizon in the same sense, they might allow information to be preserved or returned in some form. They also avoid the problem of the singularity, where known laws of physics completely break down. In a gravastar, that singularity never forms. Instead, the internal vacuum prevents complete collapse. But here's the tricky part. We can't currently tell the difference between a black hole and a gravastar just by looking at them. From a distance, their gravitational effects would be nearly identical. Light would bend around both in similar ways. Matter would behave almost the same falling toward them. Even gravitational wave signals, those ripples in space-time caused by cosmic collisions, would be hard to distinguish. Still, some physicists are analyzing subtle details in gravitational wave data to see if gravastars might leave behind different signatures. If differences are ever found, it could completely change our understanding of what's really out there. Gravastars also force us to think deeper about the nature of space, time, and reality itself. If these objects exist, they could help bridge the gap between Einstein's theory of relativity and quantum mechanics, something physicists have been struggling with for decades. In the end, gravastars may or may not exist, but the fact that scientists are seriously exploring alternatives to black holes shows just how little we truly understand about the universe. Sometimes the most mind-bending discoveries come not from what we observe, but from what we question.